Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Today we are going to do cyclic hydrocarbons from chapter 4, carbon and its compounds, part 11. This is really very important topic for your exams.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
So the first one, that is, what are cyclic hydrocarbons? We need to know it. If carbon atoms are arranged in the form of ring, I repeat, if carbon atoms are arranged in the form of ring, they are called cyclic hydrocarbons. So suppose students, if I say that I'm having a linear chain of 3 carbon atoms like this as shown on the screen, I now ask you to make it in the form of ring. What you will do? You will say, ma'am, of course, we can make this 3 carbon atoms which was in linear way. I can make it in the form of ring in this way. What you will do? You will put one carbon over here, carbon over here, carbon over here, and you will join with single bonds because in the linear chain, it was single bond. So exactly the same way you have picked up the bonds and created over here, but in the form of cycle. After that, what you did, that to satisfy the covalent bonds, as you know it, we have studied the tetravalency of carbon. That means it has 4 covalent bonds always on its sides. So to satisfy what you have done, you have put 2 more over here. That is, for this carbon, it was 1, 2 and 2 more. You have kept it 1, 2, 3, 4. And for this carbon, it was 1, 2 and then 3, 4. For this carbon, it was 1, 2 and 3, 4. So you have satisfied the 4 covalent bonds around carbon. So this is the ring shaped, that is, this is the cyclic hydrocarbon over here, which you have created as I told you. Okay, now if you see in this cyclic hydrocarbon, you notice that how many carbons we have. You will write down, ma'am, I have 3 carbon atoms. Okay, then I will ask, which bond it is having, single, double, triple. You will say, ma'am, single bond it is having. So I've written single bond. Then I will say, if there are 3 carbons, so what is the root word? So you will say, ma'am, if it is 3 carbon atoms, the root word will be prop. I said, okay. Now I say, what is the molecular formula? You will say, ma'am, it is C3H6. How? 3 carbons and 1, 2, 3, 4, 5, 6 hydrogens. So you have written C3H6. Okay. So, but if it is C3H6, what name you will give it? We will not write any other, but we will write cyclopropane because this was prop, single bond, propane and C3H6. But what you will do? But you will write down that, ma'am, it is cyclopropane because it is in the form of ring and hence the word cyclic hydrocarbon we are studying. So we will write in front of it cyclopropane. Okay. But one student stood up and said, ma'am, C3H6 is also propene. I said, okay, let us check. So I told some other student to check it is correct or not. Is it so that C3H6 is propene also? So he started checking that alkene's general formula is CnH2n. Okay, he wrote it. And then he said, ma'am, we are having 3 carbons. So let me, ma'am, arrange in the general formula 6 carbons as, ma'am, you taught us. Okay, C3 and H3 into 2 because instead of NN, we have written 3 because we were having 3 carbon atoms. So that student did it. Okay, after doing calculation, oh my God, to my surprise, of course, the molecular formula came out very correct, similar to cyclopropane, C3H6 and C3H6. Oh my God, that means it came now to the conclusion that the general formula, that means it shares the same general formula. What? Cyclic hydrocarbon and alkenes shares the same general formula, CnH2n. Absolutely correct. I patted the back, of that student who has a very keen observation, and he told me that ma'am, C3H6 is also known as propene. So that means, children, another student said, ma'am, if in the exam it is asked, draw the structure of C3H6, so what and which structure we should draw, ma'am, then? So I will tell that if the structure is asked of C3H6, so you will draw only and only of propene. If the word something comes like that is cyclopropane, then you will draw, children. Then you will draw this ring structure, and then automatically the molecular formula will come out similar, because cyclic hydrocarbons and alkenes shares the same general formula. So keep this in mind, which is really very, very important point for your exam point of view also. So children, please take care about this, whatever I have told you. Okay, another one, cyclobutane. Now students, I have told one boy to make the linear chain of butane. So the boy has made 4 carbon chain over here in front of you on the screen. Now I told the boy to convert this into ring structure. So that student, what he did, that he made these 4 carbons like this in 4 corners and then joined with these bonds over here. So he made the cyclic structure of this. Then what he did? Then he made, that is to satisfy the 4 covalent bonds. First he did that carbon is having 2 already and then 2 more attached. In this carbon, 1, 2 and 2 more attached. In this carbon, 1, 2 and 2 more attached. And this carbon, this and 2 more attached. So he made the cyclic structure of this, like this in front of you on the screen. Then I told him to make the molecular formula of this. So he said, ma'am, 4 carbons, 1, 2, 3, 4. He wrote C4. And how many hydrogens? Count 1, 2, 3, 4, 5, 6, 7, 8. So he wrote 6 C4H8. That is in front of you. Now, if you see this structure, that is the cyclic structure, which is now known as cyclobutane, we see that there are 4 carbon atoms over here, 1, 2, 3, 4. So I have written carbon 4. And carbon 4, the word root says that is bute. So I have written bute. Single bonds means that is ANE. So I have written this. And it is in the form of ring. So that means cyclo. So hence the word cyclobutane is there for this ring structure. Okay, now another student again stood up and said that ma'am, C4H8 is the formula of butene. So we said let us check. Okay, so another boy wrote the general formula of alkenes first, CnH2n, then 4 carbons were there. So he put the value of N is equal to 4 in this general formula. So we saw that C4H 2 into 4, and when he solved it, he got C4H8. Oh yes, it is having the same molecular formula as cyclobutane. So that means it is absolutely correct. That means, what did I say in the last example? That cyclic hydrocarbons and alkenes share the same general formula, that is CnH2n. So the same way which I told you in the last example, that if in the exam it is it is asked that you draw the structure of C4H8, you will only and only draw the structure butene only. If it is asked cyclobutane, molecular formula remains the same, children, but the structure you will make it as in the form of cycle, that is cyclic hydrocarbon. So always remember, children, these things you should remember that they share the same general formula CnH2n. So cyclic hydrocarbons share the same general formula of alkenes. So this is all for today's session, children. Keep on revising these kind of videos and your examples, which are really very important for your exam point of view. So with this, I wind up the session. Bye-bye. Take care. God bless.